So hello everybody, we're going to be solving an interesting integral equation, namely the integral of, from 1 to x of dt over t times the square root of t squared minus 1 is equal to pi over 3. Now I'm going to be at first focusing on how to solve this integral. It may look kind of scary, but it's not so much. So the integral from 1 to x of dt over t times the square root of t squared minus 1 can be solved by using the following substitution. T squared minus 1 is equal to u squared, from which follows that t is equal to the square root of u squared plus 1. After differentiating both sides, we get that 2t dt is equal to 2u du, and after cancelling out the 2's, we get that dt is equal to u over t du, but now we have to write this here t in terms of u. So thankfully we already have that in this here part. So dt is equal to u over the square root of u squared plus 1 du. As for the new limits of integration, we get that u1 is equal to, when you plug this one into this formula, you'll get that u squared is equal to 0, so u1 is equal to 0, and when you plug this x again into this formula, you'll get that u2 is equal to the square root of x squared minus 1. With these changes in mind, we get the new integral from 0 to the square root of x squared minus 1. I'll just write dt in front of it. After that, 1 over t is equal to the square root of u squared plus 1 times the square root of u squared, which is just the same as the square root of u squared, and of course times dt, which is the same as u over u squared plus 1 du. Now this is very nice because we're going to get a little bit of cancellation. For example, u squared, the square root of u squared is just u, and that and this u can cancel. The other thing is we have u squared plus 1, square root of that, times the square root of the same thing. So we can rewrite this as the integral from 0 to x squared minus 1 of 1 over 1 plus u squared du. And of course, this is equal to the inverse tangent or arctangent of u between the limits of 0 and the square root of x squared minus 1. So the arctangent, the inverse tangent of 0 is 0. Using the Newton-Leibniz formula, we can rewrite this as the arctangent of the square root of x squared minus 1 minus the arctangent of 0, and this of course is just 0. So the solution to our integral is that arc is arctangent of the square root of x squared minus 1. And now we have to set this as equal to pi over 3 from our original equation. So arctangent of the square root of x squared minus 1 is equal to pi over 3. When we take the tangent of both sides, tangent and inverse tangent cancel out, so we're just left with x squared minus 1 is equal to the tangent of pi over 3 and we'll get to that in a moment. The tangent of pi over 3 is simply equal to the square root of 3. Now we can square both sides, and we're going to get that x squared minus 1 is equal to 3. Therefore, x squared is equal to 4. When we assume our principal root, we're going to get that, by square rooting both sides of course, that x is equal to 2. Let me just do that in a different color. So that's the solution to our given equation. Thanks for watching.